So we are learning about greatest common factor and least common multiple. So it's really important for you to understand your important vocabulary words. What is a factor? What does it mean to be a multiple? So get your highlighter. The first vocabulary word that we are going to look at is factors. So a factor is going to be a number that divides another number without a remainder. So an example, let's say if we multiply 3 times 5, that equals 15. So 3 and 5 are factors. Okay? What makes these factors? Because if we divide them both by 15, or if we start with 15 and divide it by 5, we'll get a whole number 3. There's no remainder. So that is what the factors are. The two numbers that you multiply together to get the product are called your factors. All right, then you need common factors. That's in common, basically. And then you have the greatest common factor. That's the highest number that's going to be a factor that's common. So greatest, the highest, common, same, factor. It has to be a factor. Prime number. So a prime number is going to be a whole number greater than 1. So it has to be greater than 1 with exactly two factors. 1 and the number itself. So let's look at some examples down here. So we have a table. So these are our prime numbers are in red. So in yours is darker, the darker colors, and the composite numbers are the lighter numbers because you have black and white. So if we look at this, 2 is going to be prime. Prime number is going to be a number where the only factors, the only whole number factors is 1 in itself. So you can't really you can't divide it by another number other than 1 to get a whole number other than itself. So the factors of, let's say the factors of 5. The factors of 5 is going to be 1 and 5. Those are the only factors to get a whole number 5. The only whole number factors. The factors of 7. The only way you can get 7 is 1 times 7. So 1 and 7 are the only factors. So because those are the only factors, we can call these prime numbers. Now a composite number, on the other hand, let's do 10. So 10 can be broken down by multiplying 2 times 5. So these are the factors for 10 is going to be 1, 2, 5, and 10. So because 10 have more than two factors, more than itself and 1, we can call this a composite number. So this is called composite. Okay, so that's the lighter numbers. Let's do another one. Let's do 14. So the factors for 14, you can multiply 1 times 14. You can multiply 1 time or 2 times 7. So the factors for 14 is 1, 2, 7, and 14. So because you have more than just two factors, 1 and 14, you have, this is a composite number. Another example of a composite number is 25. So if I find the factors of 25, we have 5 times 5 make up 25. So I know 1 times 25 is our two factors, and then I have 5 times 5, but I only can put that as a factor once. So the factors of 25 is going to be 1, 5, and 25. So because there are more than two factors, 1 and 25, we can call this a composite number. So that's the difference between prime and composite. And you're going to need to know the difference between prime and composite to understand prime factorization, which is what we're going to be going over in this lesson. All right, so that brings me to a composite number. So go ahead and highlight that, which we already just talked about. So it's a whole number greater than 1 with more than two factors. And then we have prime factorization, the expression of the composite number as a product of a prime number. We're going to talk about this. You can use the prime factorization tree to find the prime factorization. So this is what we're really going to focus on, finding the prime factorization. So let's use this for an example. So we have an example up here, the old way of finding the greatest common factor, listing out the factors and then finding the one that's greatest and then going from there. Now, a lot of people struggle with their factors. So using prime factorization is a sure way to get the answer. So we're going to do the prime factorization for 54 and 36 so we can find the greatest common factor. So we're going to do 36 first. So I'm going to put 36 and I'm going to use a factor tree. Okay, so I know 36 is an even number, so I can do 2 times a number. So 2 is prime, so I'm going to circle it, and we want to keep going with our composite number. So I'm going to come over here. You can do 36 divided by 2, even though it's right there, 18. Right? Bring that number down, and we get 18. So 2 times 18 is going to give me that 36. Now, since 18 is a composite number, I want to keep going with 18. 2 factors to make up 18 is 2 times 9. Since 2 is prime, I circle it. 9 is composite because the factors are 1, 3, and 9. So I'm going to keep going with 9. 2 numbers to make up 9 is 3 and 3. So the prime factorization, I'm going to put it right here. The prime factorization for 36 is equivalent to really 1 times 2 times 2, and I'm getting that from my prime factorization, times 3 times 3. So I have 2, which is from here, times 2 times 3 times 3. And I put that 1 there because in order to be a factor, you have to be multiplied by something. So that's why I put the 1 there. So the prime factorization is, you can check it by multiplying 1 times 2, which is 2, 2 times 2, which is 4, 4 times 3, which is 12, and 12 times 3, which is 36. So I know this is the correct prime factorization for 36. Now I want to find the prime factorization for my next number, which is 54. So this is how you find the prime factorization. I'm going to put 54. I know 54 is an even number because it ends with a 4, so I'm going to do 2 times something. Now you can do 9 times 6, 3 times 18, 6 times 9, either one. But I mean, I know it's even, so I'm going to go with 2, and then I'm going to divide 54 by 2. And I know that's going to be 27 because it's right here. But if you go along with it, it'll be 27. So 2 times 27. Now 27 is a composite number, so I need to draw branches coming from 27. I need to keep going to figure out the rest of the prime numbers. You only circle the prime numbers and you draw branches from your composite numbers. Now 2 factors to make up 7 is going to be 3 times 9. 3 is a prime number, so I'm going to circle it. 9 is composite, so I'm going to keep going with 9. And then 3 times 3 is 9. So the prime factorization for 54, I'm going to write it right underneath 36, is going to be 1 times 2 times 3. And you always want to write this from least to greatest. So 2 is the lowest prime number, so I put the 2 first, and then I put my 3 times this 3 times this 3. And this is going to be the prime factorization. Now another way to write 36 is we can write it as 1 times 2 squared, since I have 2 times 2, and then I multiply that by 3 squared. So this is another way you can write the prime factorization for 36. And then for 54, and you can just get rid of the 1, you can write 1 times 2 1 times, so I'm not going to put an exponent because if no exponent is there, the exponent is automatically 1. And then multiply it by 3 times 1, 2, 3, the third power. So that's a shorthand way of writing the prime factorization. But here's the prime factorization, and you can check that of 54 by multiplying 1 times 2, which is 2, 2 times 3, which is 6, 6 times 3, which is 18, and 18 times 3, which is 54. So I know this is the correct prime factorization for that number. Now to get the greatest common factor, you want to pull out the greatest, the common prime factors. So we have 1, so I bring the 1 down, times 2, they have in common, so I bring it 2 down. You only circle what they have in common, and you only pair it once. So I can factor out a 3. So I'm going to put a 3 here, times 3, and I can factor out one more 3 because I have it in both numbers. And this is how you end up with the greatest common factor. So we have 1 times 2 is 2. Bring down everything that I did not use, or I can do 3 times 3 is 9. And then I have 2 times 9 is 18. So the greatest common factor is 18. The greatest common factor of 36 and 54 is 18. So that's what we're going to be working on the next page. The next vocabulary words, multiples. So get your highlighter. What is a multiple? Remember, in order to get the multiples, you have to multiply. A multiple of a number is the product of a number and a whole number greater than 0. Okay, in order to get the multiples, you have to multiply. So a common multiple is obviously going to be the multiples that they have in common, or that the two numbers have in common. The least common multiple is going to be the lowest number that they have, the lowest multiple that they have in common. I mean, you can read those vocabulary words. The vocabulary words that you want to focus on are the ones that you're going to see on your Quizlet cards, because your vocabulary quiz will have those same words. All right, and then we have a definition for distributive property. So flip to the next page. So multiplying a number by the sum or difference gives the same product of multiplying by each. So basically, we kind of talked about this a little bit. So if I were to write 5 times the sum of 2 and 3. So we know we can add 2 plus 3, which is 5, and then multiply by 5 to get 25. But you can also apply the distributive property. Because you have the sum of 2 and 3 5 times, you can distribute this 5 into the 2, which is going to be 5 times 2. Remember, parentheses mean multiplication. So you need to multiply this 5 by every term inside of the parentheses. So you have 5 times 2, the plus sign is going to stay, and then you multiply 5 times 3, 5 times 3, and then you evaluate. So 5 times 2 is 10, and then 5 times 3 is 15. You bring that plus sign down, and you still get the same answer, 25. So what this means is multiplying by the sum or difference gives the same result. So if I evaluate my parentheses and get 5 in the parentheses, and then multiply by that 5, I still get the same result. So you can apply the distributive property, or you can evaluate using the order operations, meaning you're going to evaluate the parentheses first and then multiply by the number outside of the parentheses. Now, if you have variables, you only can distribute unless you can combine like terms, but that's a whole nother lesson that we have to talk about. All right, so here's an example of prime factorization. You have your steps. You want to circle your prime numbers. Remember, so you have to know your prime numbers, which are right here on the bottom of page number 72. You have to know your prime numbers because those are the numbers that you want to circle, and your composite numbers, you want to keep going with those. You want to draw your branches. So you want to write your two factors. So you write 30. Do not circle 30 because 30 is composite. So you write 10 and 3. 3 is prime, so you circle it. And then you want to draw 2 branches to make up your other factors of your composite numbers. So we have 2 and 5. And because 2 and 5 are prime numbers, you circle them. And then you have the prime factorization. You always write the prime factorization from least to greatest. So the lowest number, remember the 1 is there, but you don't have to write it. So the lowest prime number is a 2, so that's why you write the 2 first. The next lowest prime number is a 3, so you put 2 times 3. And then the last prime number is a 5, so you put times 5. And you can check to see if it's correct by multiplying those numbers. So we have 2 times 3 is 6, and 6 times 5 equals 30. So because the prime factorization is equivalent to the original number, you know the prime factorization is correct. So here is another example of how to find the greatest common factor of two numbers. So we want to find the greatest common factor of 42 and 28. So we already have the prime factorization here, but if you wanted to do the prime factorization, you would draw your 42, and then you will use your factor tree. So I know 6 times 7 is 42. 7 is prime, so I'm going to circle it. 6 is composite, so I need to draw my branches and keep going. 2 factors of 6 is 2 and 3. 2 and 3 are both prime, so I'm going to circle those. So the prime factorization for 42 is 2 times 3 times 7. So this is where that prime factorization came from. And then the prime factorization for 28, 2 factors to make up 28 is 2 times 14. 2 is prime, so I'm going to circle it because the only whole number of factors is 1 in itself. And then 2 factors to make up 14 is 2 times 7. You never want to have a 1 in your prime factorization tree. Never have a 1. So we're going to circle 2. 7 is prime, so I'm going to circle it. So the prime factorization is 2 times 2 times 7. So that's where this came from. And then you want to factor out the prime factors that's common. So we have a 2 that's common. So to make up the greatest common factor, you will do 2. And then you can factor out a 7 from both of those. And since those factors, we're going to multiply them. So you have 2 times 7, and that's how we got 14, the greatest common factor. So the greatest common factor of 42 and 28 is 14. So if I wanted to rewrite 42 plus 28 using a greatest common factor in a distributive property, you have to factor out the greatest common factor, which is 14. And then you'll say, okay, 14 times what number will give me 42? Well, if you go back to the prime factorization and see, if you factored out the 2 and the 7, you have 3 left. So that means 14 times that other factor 3 will give you the 42 that you need. And then you put your plus sign in the middle, and you have to say, okay, if I'm starting with 28 and I factor out a 14, 14 times what number will give me 28? Or you could say 28 divided by 14 is what number? So if you go back up here to the prime factorization and factor out that 2 and that 7, which is equivalent to that 14, you can see the other factor that you need is the 2. So that means 14 times 2 is the 28. So if you wanted to rewrite using a greatest common factor in the distributive property, you will get 14 times the sum of 3 and 2. Now, if you factor out a 7 and the numbers inside of the parentheses can be simplified, then you have the wrong answer. So now that brings us to the distributive property. So remember, when you apply in the distributive property, you want to distribute that number outside of the parentheses and multiply it against every term inside of the parentheses. And remember, a term is separated by a plus or minus sign. So we have our objectives here. You can go back and read those. Just an example of why the distributive property works. So if you have, so this one right here is represented by 3 times the sum of 5 and 7. So you have the sum of 5 and 7. So the sum of 5, 1, 2, 3, 4, 5, plus 7, that'll be 6, 7, 8, 9, 10, 11, 12. So the bottom factor, or the top base, is 12. So now you have 12 3 times, which is equivalent to 36. So you have a total of 36 total boxes. So how did we get that? We added up the parentheses first. We got 5 plus 7, which is 12. And then 12 3 times is going to give us 36. Okay? So that's using combining our parentheses first and then multiplying it by the 3. Now over here we have it separate. So over here you have 5 3 times or 3 5 times, which is going to give you that 15. So I can rewrite this as 3 times 5, and that's going to give me that 15. Then I bring my plus sign down, and then I have 3 7 times or 7 3 times, which is the same answer, 21. So I'm going to write that as 3 times 7. And then I'm going to keep my plus sign, and I'm going to put 21 here. And if I add those up, I'm still going to get the same answer, 36. So it doesn't matter if you combine your parentheses first or if you apply the distributive property. You still get the same answer. Now, notice here that we have a common factor, 3. So you can factor out the 3, and then you will have 5 plus 7 in the parentheses. And that is how you would take it back to the original. That's how you can prove that they are equivalent. So let's do an example here. Flip to the next page. And we're going to just do 2 of these, and then we'll do the rest during class. So this is how you can rewrite using the greatest common factor in distributive property. The first thing you want to do is figure out what is the greatest common factor. You can use prime factorization. We're going to practice this down here. So the greatest common factor of 50 and 15 is 5. So you can factor out a 5. So if I factor out the 5, I want it to be equivalent to 50 minus 15. I'm factoring out the 5. And then I'm going to keep the minus sign in the middle, Then I want to say, okay, 50 divided by 5 is 10, so that means 5 times 10 will give me back the 50. You want it to be equivalent. The minus sign stays, and then you look at that, the 10, that's the other factor. And then you have 15 divided by 5 is 3, so the other factor must be a 3. So that's how you will rewrite it using the distributive property and the greatest common factor. Notice that the numbers, the terms inside of my parentheses cannot be simplified further, so I know this is correct, the correct greatest common factor. Okay, so that's how you do that. So let's go over a couple of examples. We want to use the distributive property and greatest common factor to write the expression equivalent, and we want to show our prime factorization. So don't take up too much space here. We have a lot to do here. So the first thing we want to do is leave a little bit of space underneath so we can rewrite, factor out the greatest common factor, and we want to put the parentheses, the sign in the middle should stay as a plus sign. All right, so the first thing we want to do is find the greatest common factor. So I'm going to do a prime factorization for 16. So we have 2 times 8 is 16. And then 2 is prime, so we circle it. 2 factors to make up 8 is 2 times 4, 2 and 4. I'm going to circle 2 because it's prime. 4 is composite, so I'm going to write 2 times 2. And these are prime numbers, so I'm going to circle them. So my prime factorization, I'm going to put prime factorization for 16 is equivalent to 1 times, but I'm not going to put that, 2, that's from here, times 2, you always write it from least to greatest, times 2, but they're all 2, so it doesn't matter, times 2, and that is how I got 16. And you can check 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. Now I'm going to do the prime factorization for 40. So I know 5 times 8 is 40. I'm going to circle 5 because it's a prime number, and I'm going to keep going with 8 because it's composite. Then I have 4 times 2. I'm going to circle 2 because it's prime, and I'm going to keep going with 4 because it's composite. 2 factors to make up 4 are 2 and 2 times 2. I'm going to circle those because they are prime. So now I can write the prime factorization for 40 is equivalent to, you always want to go from least to greatest, so we have 1 times 2 times 2 times 2 times 5. And that's the prime factorization for 40. And you can check it by multiplying your numbers. 2 times 2 is 4. 4 times 2 is 8, and 8 times 5 is 40, so this is the correct prime factorization. Now we want to find the greatest common factor. So you want to factor out the numbers that they have in common. So we can factor out a 2, because I have a 2 in both of the numbers that I can factor out. And these are factors, so we're factoring out the common factors. I can factor out, and I'm putting multiplication in the middle because they're factors. I can factor out another 2, so I'm going to bring that down. And then I can factor out another 2, so times 2. And then I cannot factor out a 5 because 16 does not have a 5 as a factor. And I cannot factor out another 2 because 40 does not have another 2 as a factor. So the greatest common factor is just going to be these numbers here. So I'm going to multiply 2 times 2, which is 4. And then 4 times 2, which is 8. So the greatest common factor of 16 and 40 is 8. So I'm going to go back up top. This is the greatest common factor, and that's the number that I'm going to factor out, 8. And then I want to multiply 8 times what number will give me 16? That'll be a 2. So I can come back down here to my prime factorization and notice that I have 2 left over. So that's the other factor that I will multiply to get the 16. And then 8 times what number will give me 40? And that's a 5. And you can go back to your prime factorization and see that you have a 5 left as a factor. So whatever you have left as a factor, you can multiply them to get the number that you need to multiply the greatest common factor by to get the original number. So now we have our answer. We have 8 times the sum of 2 and 5. So if we multiply, you can check your work by multiplying 8 times 2, which is 16. And then keep your plus sign and then multiply 8 times 5, which is 40. And we can see that it's equivalent to the original. Okay, let's do one more. So for this one, I already know the greatest common factor is probably 4. But let's go ahead and do the work. So we want to factor out the greatest common factor. So you put the greatest common factor outside of the parentheses. I'm going to use prime factorization. Let's go ahead and block this off. I'm going to use prime factorization. So I'm going to do the prime factorization for 36. I know 6 times 6 is 36. Both of these are composite numbers, so I'm going to draw my branches. And then I know 3 times 2 is 6. Both of these are prime, so I'm going to circle them. And then 3 times 2 is 6, so I'm going to circle those because they're prime. So the prime factorization for 36 is equivalent to 1 times 2, where did I get that from? Here, times 2. Remember, you have to put it in order from least to greatest. So the lowest prime number is 2, and I have that twice. And then I need to multiply that by 3, and then I need to multiply that by the other 3. So you can check it by multiplying, and you only put your prime numbers in the prime factorization. It's called prime factorization for a reason. Only the prime numbers go into prime factorization. So we have 2 times 2, which is 4, 4 times 3, which is 12, and then 12 times 3, which is 36. Then we want to do the prime factorization for 8. So we have 4 times 2. 2 is prime, so we circle it. 4 is composite, so we keep going with 4. 2 times 2 is 4, so now those are prime, so we circle them. So we can conclude the prime factorization for 8 is 1 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So I know that is correct. Now we want to find the greatest common factor. So what can we factor out? We can factor out a 2. We can factor out another 2 because they have another 2 in common. And that's it. Because 36 does not have another 2 to factor out with this 2, and 8 does not have 3's to factor out with either one of these 3's. So the greatest common factor is just going to be 2 times 2, which is 4. So that's the number that we're going to factor out of the parentheses. And then we have to use the distributive property to figure out what number we need to multiply 4 by, because remember, parentheses mean multiplication. What number do we multiply 4 by to get 36? Well, if you come back down here to the prime factorization, if you factor out 2 times 2, what do you have left? 3 times 3. So that means the number inside of the parentheses is a 9. And then 4 times what number will give us that 8 after that plus sign? So if you factored out 2 times 2, which is 4, if you multiply by that other factor 2, you'll get that 8. So we need a 2 here. So it says 4 times the sum of 9 and 2. And that's the answer. I'm going to look at the other 2 in class, and we're going to practice some more. I want to bring you to word problems because we're going to introduce word problems. So how do you find the greatest common factor in word problems? So you want to know these 2 definitions. You want to use the greatest common factor in word problems when you're trying to find the greatest number of identical groups. So that's the main thing. And when do you want to use the least common multiple? When you want the least amount of times an event will occur again. So you want the least occurrence again. So you could think of it like that. So you want to understand, you want to know these. When do you use the greatest common factor in word problems? And when do you use the least common multiple in word problems? And then we're going to get into that in class.